real-life scenarios do you see this catalyst helping the most?
Satellite connectivity together with 5G is used for many different use cases. For digital inclusion, to connect remote places, right? Or mobility as well, so we can deploy 5G in a cruise, for example. But there is, in concrete, for this catalyst, what we have done is to show how it applies for disaster recovery. So basically in here, what we are doing is deploying the satellite connectivity with a private 5G connectivity that enables the emergency response teams to get coordinated, but also the people that are in distress, right, that they can get connected. You can even potentially find people that will get a 5G signal, right, and connect and triangulate and find people, right? So it's a real thing. We're already providing it. We have been supporting many companies and, you know, in disasters, in natural disasters. So it's a real thing. And what we're doing is show how we can coordinate better, how we can get prepared, how we can interoperate, so to support faster.
Celfocus started with service orchestration for 5G and SATCOM 2. What was the goal?
So there, what we did was to do the resource provisioning, meaning we would, upon an order, service order, we would provision the 5G core resources, so that, of course, we can have service provided at the remote location with the UPF, the AMF, and all those components of the 5G core that are necessary for the service to be provided, and data would pass and serve the customers.
How do you see Digital Twin adding value to this catalyst?
So under natural disasters, there are two main aspects that we have to consider. Is speed, in which you are activating the connectivity. And this goes in hand of this interoperability, because at the end, every minute counts, right? We're talking about saving lives. So you need to go with a mobile, for example, imagine a truck with antennas, and then you go there, and by the time the truck arrives, you have the connectivity put in place. So that's one, right? This is speed. The other one is about coordination and visibility. So basically, you need to know where have you deployed connectivity and who's connected, right? Because every time, if you are not providing connectivity, the emergency response teams might not be doing the right thing. Maybe are taking random decisions, right? Or you are not going to be that efficient. So by having these digital twins, you can ensure that you have visibility on the network elements. That's one part, the physical part. But also, you can know where the emergency response teams are working, right? Where are deployed. So it's like a digital twin also of the emergency response teams.
What was the objective of adding Digital Twin to this year's Catalyst?
On top of this resource orchestration, also the service delivery part, so delivering connectivity to terminals, so 5G provisioning of the service, not only resources, so adding that, but also the digital twin part, which is in its first iteration, collecting topology information, and the idea is that it grows into having not only network, but also service data, so that we can get this AI readiness, where on top of it, we can work with AI algorithms, such as anomaly detection, predictive algorithms, and of course with not only network and service data, but also people that are using the network, whether they be firefighters or respondents to a certain disaster, so they can be we can be aware of what they are doing on the terrain and how to help them more efficiently while doing their operations and saving lives more efficiently.
What is the main differentiator of this catalyst, and how close do you think it is to a real-world use case?
So this type of connectivity and this type of solutions, I would say it's a real thing already. We provide and we support governments and organizations to respond to natural disaster. The differentiator of this catalyst, what it shows is that by adding interoperability, but getting prepared and having all the different parties together talking the same language, you can respond faster. And moreover, you can even have visibility on what's going on, right, through the digital teams. I think that's the major differentiator, right? Is the speed, and then it's this transparency. And interoperability and the standards make a crucial role.
What is the subsequent iteration for next year's Catalyst?
So instead of having only a digital twin, which is of the network digital twin, and of course those serve operational and planning use cases as an example, but instead we can have a real life digital twin, which is not only providing that, so performance of the service, understanding whether the connectivity that is being provided to people on the ground is correct and it's according to their needs, but also how they are moving on top and how we can help them and have their information to help them doing their job on the ground. So that's where we see value. So it's not only network digital twin, but rather the situation or contextual digital twin that we want to have here as a solution. And that's probably where we go next year, hopefully.
Where do you see the Catalyst project heading next?
So we have covered this year a lot of ground, right? From the activation with the AI Empower to the closed loop service assurance, to the also the digital twin and the settlement, right? All the billing and revenue sharing. What we're thinking for next year is to evolve more into the self-service, so allow the virtual network operators to manage the network autonomously without having to call the satellite connectivity providers. And then the other area where we see a lot of value is in the digital twin aspect. In here, what we are seeing is that we can introduce way more knowledge and more AI to identify patterns, to the digital twin get a more pivotal role on reacting towards the changing scenario of a natural disaster. So that potentially is one of the areas we would like to explore and expand.
Winner for the Tech for Good category is SATCOM with an Edge Phase 3.